Good morning, everyone. It's Tuesday, May 19th. Welcome back to another lesson about stars. And today we're going to talk specifically about our own star, the sun, and some of the features of the sun. It should be a short lesson today. It should be a short quiz. I'm thinking like 5 questions. All right. So make sure you pay attention to the details, and I'll try to really point out the things that you're going to need to know for that quiz at the end. All right. So when we start off, the sun has layers. All right. And the sun has a core, it has a surface, which is kind of constantly in flux, and then it has layers of its atmosphere. And you can see in this picture a whole lot of different parts that are labeled, which would be really difficult to understand or replicate if I asked you to do that. So it's not hugely important, but I do need to just go over them so that you understand that the sun has different parts of it. All right. Now, in the past, I have said things like lightning is 5 times hotter than the surface of the sun. That's true, but it's kind of a trick. The surface of the sun is not very hot compared to the rest of it. Now, it's scorching hot, 6,000 degrees Kelvin in that photosphere portion of the sun, which you can see right here. That's way hot. It'll fry everything quickly, all right? But it's one of the coolest places on the sun temperature wise. There are other locations that you can see in this picture that we'll talk about. The chromosphere, which is further out, like towards the atmosphere. That one is even hotter yet. And when we get out into the atmosphere around the sun, it actually gets up to in the neighborhood of 2 million degrees Kelvin. Super, super hot in the atmosphere. So the sun has um, different characteristics and its different layers, and you just need to know that. All right, you don't need to know the specifics about each one of them. Just know there's a core, there's a surface, and there's an atmosphere. And the atmosphere is the hottest part of the sun. That's definitely going to be on the quiz. I hope you're paying attention. All right. Now, as we look here at these pictures of the sun, we start to see some different features that are on the sun or near the sun or come off of the sun. Each of these is also going to be on the quiz. The first are sunspots, and you can see those are those dark areas that you can see on the surface of the sun. Um, they are a little bit of an unknown. They are a cooler area in that particular part of the sun. That's why they appear dark. They can last for varying amounts of time. They also, it's really neat, is they show us how fast the sun material in the sun is rotating. It tells down here that near the equator it takes about 25 days to complete one rotation, and near the poles it take about 35 days. So the center is moving faster than the poles, which is kind of interesting, and we wouldn't know that unless there were sunspots to look at. A neat thing about sunspots is that there are times when there are a lot of them, and there are times when there are very few or none of them, uh, pointing towards the Earth. So that actually happens in about a 10 to 11 year cycle, where we have sunspot maximums, and then another 10 or 11 years later, we have another sunspot maximum, and in between time would be considered a sunspot minimum, where we have fewer and fewer of them. Now, you might think, well, gosh, if there's a lot of sunspots, those are cooler areas, so shouldn't it be cooler on Earth during those times of sunspot maximums? It's a good thought. It doesn't particularly line up well with our temperature graph, our average temperatures on Earth. If that was the case, every 10 or 11 years, temperature would drop and then go back up again, and then it would drop. And that's not really the case. It does have some small effects, but not a whole bunch. All right, so those are sunspots. Next, we have prominences or flares. Prominences blast material from the sun into space, at speeds ranging from 600 kilometers per second to more than 1,000 kilometers per second. These huge eruptions of material that are coming off of the sun. I'll try to look up here. Let's see, prominence right here. Almost think like an explosion of superheated gas headed out into space very, very rapidly. That would be an example of a prominence. All right. Solar flares. They are also something that you can especially see them in an eclipse because it covers up the surface and you can see them shooting off around the edges of the sun. But again, super hot gases ejected from the sun. All right. By the way, superheated gases, plasma. All right. Keep that in mind. Now, one of the last things that we'll talk about are coronal mass ejections, or CMEs. They occur when large amounts of electrically charged gas are ejected suddenly from the sun's corona. And these things can occur as often as 2 or 3 times each day during sunspot maximums. Now, here's an example of a solar flare and a solar prominence. It's a lot about size, but the coronal mass ejections, which are generated by magnetic fields above the sunspots, they actually are responsible for a few things. They're not terribly dangerous to life on Earth. However, the electromagnetic material that they send out, the electrically charged gases, they can mess with our satellites. They can also really produce something cool because those particles, when they interact with our atmosphere, cause the northern lights, which are really neat. Hopefully, you've had the chance to see them. You might have to go a little further north in a little bit darker location because of light pollution. But if you ever get the chance, I hope you get to see the northern lights. Those are just electrically charged particles that have been ejected off of the sun that interact with our atmosphere. And those typically will come from a coronal mass ejection. All right. Probably going to be on the quiz. What causes the northern lights? All right. I would pay attention to that. All right. We'll finish up today. I promised you a short lesson about the sun being an average star. It's hugely important to life on Earth. Without it, there wouldn't be much. I can't say none anymore because we found life forms that really live without benefit of receiving anything from the sun, whether they're deep inside the earth or in ice. But for us, the sun is hugely important, but it's hugely plain and average. As it says up here, it's middle-aged. Its absolute magnitude is average. It's not particularly hot or particularly cold. It's in that yellow category. So it just so happens that we are located just the right distance, called the habitable zone, just the right distance from the sun so that it's not too warm, it's not too cold, it's just right. Kind of like, I don't know, that one story about the bears and the porridge thing, which I can't remember what that is. Light from the sun takes about 8 minutes to get to Earth. So if the sun were to burn out, just like that, we wouldn't know about it for 8 minutes because there would still be 8 minutes worth of light heading towards the Earth. Don't worry, it's billions of years down the road before our sun goes through kind of its end cycle where it will expand tremendously, and then eventually life here on Earth is not going to prosper in the way that it does now. Billions with a B years down the road. So don't lose any sleep over that tonight. All right. That is a little bit of a rundown on our sun. It's a nuclear furnace. It has a core. It has a surface. It has layers of its atmosphere. The temperatures in the sun, the layers in the atmosphere are the hottest. The atmosphere of the sun is the hottest. It has surface features like sunspots, which are dark. cooler areas that go in a 10 or 11-year cycle. It has flares and prominences, coronal mass ejections, which send electrically charged particles towards Earth, and they hit our atmosphere and they form the northern lights. And to wrap it up, our sun is just average. Not too hot, not too old, not too young, not too cool, just right in the middle. All right, so pay attention, do your best on those maybe 5 quiz questions for today. If you need my help, email me, message me, request a Google Meeting, and I would be happy to help you. All right, so with that said, tomorrow's the last day of new material, and it's not going to be about stars. All right, make sure you tune in, and I will talk to you all tomorrow, and I hope you have a great day.